Okay, hello. I wasn't planning on streaming, but this is going to give me a little bit of accountability. This is the camera. We're gonna do some R Shiny visualizations. Realistically, we're adapting a script of mine so that we can actually visualize my research a little bit better. Let me do this. Share. Copy link. And just gonna put this up on the old YouTubes. Hey, we're going to visualize some R Shiny results. This should be a really cool visualization combining geography, phylogenies, and R expertise. Just click on the link and join in. Just have a chat. Maybe work on your thesis that you're neglecting to do, because I'm doing the same thing. Hey, we're going to visualize some R Shiny results. You're going to hear that twice. Okay, cool. And last thing is just a link. Sorry I always gotta do this right at the start, but I don't know how to get the link ahead of time. But there we go. And currently Instagram is the only time we get it. Okay, so what are we gonna do today? First we're going to adjust this camera just a bit. Apologies if it cuts out. Okay, so what we're going to be doing is basically I have results. I have results from my research, and I'm struggling to understand a little bit about what's going on. So let me show you what I'm working with. Let me show you and why I need to visualize them the way that I'm trying to visualize them. Luckily, I already have a framework we're going to be working on from a different project using the same methodology. So we're going to use that, but I'm going to simplify it, make it easier to work with, and then, yeah. I should actually reach out to the author of this package because he would benefit from including this. And it is after 4:20 p.m. Pacific time. So, okay, project open recent Mesoamerican provinces. So I've been messing around in QGIS to visualize the results of my research a little bit and to kind of make sense of it. I'm at the point where I don't have to do much analysis, but I have to do a lot of interpretation. Sorry, let me also just realize that my music shut off. I'm listening to Miss Mellow, by the way. Hoobla, cool. So, QGIS is taking a little bit. Okay, so I opened up this project file on my laptop, which is running a different version of GIS, so I need to update both, but I guess I had them at different times. Okay, well, while this figures stuff out, basically I have regions that are phylogenetic histories of the herpetofauna of Mesoamerica, so all the reptiles and amphibians. I ran it separately. Right now I can't zoom, unfortunately, but these are amphibians, so just thought you'd like to know. So what we're going to do is, one, I'm actually going to change over my Stream Deck. Hold on here. Yes, so if this is all, let's just double check everything really quickly. Okay, so zoom environment's messed up. Okay, we'll fix that. Just 1 second. So, what I'm doing is I have a Stream Deck. Cool. Zoom console, that looks great. And zoom play. Why was only zoom environment messed up? That's so weird. Okay, and then me, small, and then big. Haha. So I have a little, let me show you what I'm working with. This is called a Stream Deck. Allows you just to switch between stuff. I got it on a production, actually, for, yeah, but it just makes things easier. I actually program a lot of macros into it for grading to like click stuff and add zeros and ones and all that fun stuff. But yes, so I don't know why. Oh, you know what? QGIS might be. Oh, it literally just crashed. Okay. Oof. Yikers. Okay, let's open that back up. Oh god. I mean, it's not too difficult of a project to get back up and running in GIS, but still, it's just annoying. Sorry, I heard like a noise, and it might have just been the music. But there's a few neighborhood cats. It's just someone who has outdoor cats, and earlier today they hopped up onto our Windows screen and was like hissing at Java. So I'm kind of being a little bit protective cat dad at the moment. So I'm gonna keep my ear listening just in case that happens again. Okay, so this time it worked. Okay, so let me show you what I'm working with. So let's get rid of that. Let's get rid of that. Okay, so this is an amphibian phyloregion. So if we add back onto the world topo, so it makes it a little bit easier. This is Mesoamerica. Mesoamerica, as I've defined it. Politically, Mesoamerica is Central America and Mexico, so basically everything between North America, South America, but I don't like using political units to define biogeographic regions, so I fudged the edges a little bit and used some other metrics to get that. Anyways, doesn't matter. Essentially, it's a less political Mesoamerica, more biogeographic Mesoamerica. So with this, these are, again, the amphibians. So it's saying that each of these regions, I took all of the occurrence records of all the amphibians and their phylogenetic information, so how are they related to one another, evolutionarily speaking, different species, and then using some clustering techniques, we got this methodology, which says, hey, all the taxa found in region D, for example. Let me actually change over these labels, because this is for a different analysis. Hold on, let me change it from the RASP layer to cluster. Okay, so right here, region number 4 would be considered, all the taxa that are found there are phylogenetically similar. They're clustered together. And then so on and so forth for all the different taxa, all the different species. Now, in order to understand these results, I need to understand, well, hey, cool, this is region number 2. The groups are phylogenetically clustering here for whatever reason. What groups are here? Why? Why are they clustering? Are there high species of endemism? Is there a particular taxonomic group, a family, a genus that is found only here, and it's a little bit unique? Now, that's a bit difficult to do. I can do it manually, just keep changing things, but I thought that kind of sucked. So instead, I'm going to make an R-Shiny visualization. So let's go here. So basically, I have this old visualization from a similar project that also does phyloregions for the world's turtles. Ooh, apologies. I did not set up my space properly. Okay, coffee there. Drink there. Ashtray there. Various substances there. Microphone here. Keyboard hither. Cool. So, actually, I'm going to switch this around so that you get a little bit of a better mic experience. So, I cannot make this shotgun, can I? No, but I will switch it to this mode. I believe you'll get a little bit less keyboard clackety-clackiness, so, yes. But anyways. So yeah, I did a similar project for the world's turtles, represented here in this script. So what I'm just going to be doing is taking all of this information, and it's pretty straightforward. It's not a very complicated, oh, sorry, no, this information, I was looking at the wrong thing. This is an R-Shiny app. So R-Shiny allows you to make very simple applications that you can visualize things in R. So all I'm going to do is I'm going to take this and adapt it for my own study and make it a little bit less specific. As you can see, these are for the turtles, so Pleurodires, Trionychidae, Echinosternidae, oh god. But I want to make it more general so it doesn't have those clades, because that's just that was just for that specific visualization. So anyways, okay, cool. So I'm going to copy and paste everything first. And then I'm going to go through and I'm going to remove things. So now we're on a new script. Okay. So I do not need this fluid row. I'm going to keep it. So R-Shiny is, like I mentioned, it's a basically think of it like a different type of coding for R. It's a more advanced version of R, I guess is one way to put it, where you can make very simple visualizations that showcase, like if you want to filter out a box plot and only show specific ones. I'm trying to think of if I have a R Shiny app. Actually, hold on. Phi Global Turtles, open a new window. I might have it. Will this just work? Ah. Oh. What did I just do? Okay. Yeah, so for example, this is an R Shiny application that I made that showcases some of the regions for the world's turtles. So you can see I can manipulate it, I can look at it a little bit closer, I have different layers I can add. This was a test, this wasn't the full one. But now let me see if I have, I don't know why I exited out of it, Phi Global Turtles. Let me see if I actually have, I have it somewhere. I want to show you what we're going to make so that we can understand it better. And I think if I go to my Notion, one turtle photo regionalization, let's go to the paper, introduction, nope. Got the link to my Shiny app. So this is the Shiny app that I made for the turtles, assuming that it just works first time perfectly, which, you know, is not a very fair assumption, knowing me. But this should work because the data's been uploaded. It was for my advisor, so I have like a little message of like, hi Todd, this is what I made. But give it a second to load up, and we will show you what I have here, because we're going to be, yeah, here we go. So these are the phylo regions for the world's turtles, okay? And what I've done is, so phyloregions, same method as before, like I just mentioned. Take the phylogenetic history of some group and their geographic coordinates, and you can just say that, hey, this region over here in Central Africa is its own region. Now, what I have it do is that if I want to select a phyloregion, so right now it's selected 45, which is the US, so let's do 58, for example. 58 is down here. It highlights it in red. It shows me the full phylogeny and where the groups are, so they're actually highlighted in blue. It's very hard for you to see because I didn't have zoom, but on the left-hand side it shows a truncated phylogeny, and then just some summary statistics here. So we're going to recreate this, but make it much simpler. So we'll still show the full species tree, but we are going to remove the different groupings because I don't have that. I can make it show the node labels, but I'll figure that out at a separate time. Basically, I want to make it simpler and more generalized so that I could apply it to any phyloregion visualize any project in the future, because I anticipate myself doing it often. Now, I'm actually going to leave that up in the background. Cool. So, also, this is where I write out everything for my research. This is how I keep track of literally everything. Okay. Cool. So let's go back to R. Now, what I need to do is we are going to want to keep the, which phylo region? Hold on. Because I was adding this to my R package. Let me see what that's at. Research. Visual viz ACR Shiny. Let me just see what this looks like. Phylo SF. Wait. This is a different thing. Oh, that's a totally different thing. Okay, file, open file. I actually do not have anything in here. Okay, cool. No big deal. Okay, so we're going to keep this. So let's define some variables up here. So I'm going to call it a phylo. We're going to say PR, and we're going to say presab. Okay, so as dot phylo, as dot, I'm not sure yet, and presab is going to be as dot matrix. Okay, so we're going to have these three things. Okay. So this one is pulling from hydrophilo, which is... okay, I see. So basically, this first little bit is just getting the... it's a selector. So select, let me zoom in for y'all. Select what phyllo region you want highlighted here. Okay, so I'm going to keep this, which phyllo region. This, I'm going to say is going to be pr.cluster, and let's do this. Okay, so code, oh, what is this? It is, oh god, there's a keyboard shortcut for this. We're not gonna worry about it. Okay, PR. Okay. I'm going to I'm going to keep the boxes, but I'm going to specifically remove them. So what you do in an R-Shiny application is first you have your UI, and this is the user interface. So this is what you actually make it look like. This is what you make it look like. This is how you actually build out the application. So it would be, in this case, we have the title, which just says up at the top. Here's the title. Fluid rows are different rows. There's lots of layout stuff that we have going on here. And all it's saying is that this is a select input. So make which phyllo region, choose which cluster. And then here we have columns and rows, again, just organization. And then a checkbox input, then maybe an HTML output, a plot output, a leaflet output. So you're just saying, hey, I want to put stuff in certain locations, and using the width, the columns, the rows, you can actually specify where they go. So I could say, put the checkboxes here, put the map here, right? That's what I'm doing up there on the UI. So I also have variables that I've made here. So select input region, which region, right? So down here, I have inputs and outputs, which a lot of these are inputs and outputs. So there are things that are outputted, and then there are things that are inputted by the user. So someone will say, I want to see this, I want to see that. Now, this, okay, clustdf. So what is that supposed to mean? This is a cluster data frame. Okay, so let's see. So I keep opening up this one. That's incorrect. We go to app, and then I need to load in this data. Okay, so we're gonna go to there, research. Oh god, no, it isn't here. It is in the PhyGlobal Turtles. It is in, oh my god, why is this so badly organized? This turtle project got nuts. Phyllo region visualizer, and then data. Here we go. Yes, okay. So this is my data. Okay, more. Move, open selected in source pane, open each file in new columns. Okay, we'll just make this the working directory. How about we do that? Okay, more. Set as working directory. Okay, cool. And we'll just load the data so that we know what we're working with here. So this is all the data. Oh, you can't see this. You can't see what I was doing. So this is the data that we have for the turtle one. And I see what it all is. There's a lot going on here. So we have the bioclimatic variables, we have the canopy analysis, which is another analysis I had to do. We have clustdf, which is the one I was trying to figure out. So this is a summary statistic one of the cluster, the number of cells, mean edge, count edge, and richness. Okay. So df_filt. So this is just looking. Reactives are things that are waiting to react on a page. Should be back there. So that's what we're looking at there. So A, we're getting the row names from clusters, which is here. Wow, what is this? Input, region 1. So this is saying we only want to get from clusters the region. So this is a data frame that is showing each cluster and all of the cells within it. Okay, so this we might be able just to make ourselves via our PresAb matrix and our phylo region. We do need to define what we want our phylo region data input to look like. And fortunately, we do have a lot of different options. So if we go here, and let's go to, let's do amphibians. Let's work with the amphibians data set. Do I want to load it? Yes, I do. Okay. So here we have our amphibian data. Now, whenever we make those phylo regions, we get these outputs called PLJackA. And what I'm thinking is I can utilize all of this to get my answer, to get what I need. Okay, so how many things are in there? Is it just 3 objects? Incorrect number. Okay, it's not it's just a data. My R is being weird. Always great. Incorrect number of dimensions. That means nothing to me. I've never seen that error before. Okay, well then we're going to ignore all of them, because that's what I do best. Okay. So, how do we want this to look? Okay, I'm going to remove a bunch of stuff. Okay. So we have our phylo. We know we're going to have a phylogeny. That's fine. Cool. So this will be our phylo. With our PR, we have our PresAb matrix, which is awesome. Okay, and I think we should just have our phylo region. I think that should just be our input, is just take the phylo region object. Okay, as dot phylo region. Okay, that is also not a function. Okay, yeah. Okay, so let's just work off of this. So PLJackA. Okay, and then here we have our phylo object. This is going to be tree. I am feeling pretty confident that we can do all of this just based off of these objects. So phylo, PR, PresAb. That's what we're going to work with. Okay. So now this first one is from the cluster data frame, which here is saying that, okay, cool, each cluster there. Now, what I'm wondering is I might have a script that does this, that changes it over to Phi Global Turtles scripts. It might be one of these. That doesn't look right. Let's just check visualizations. I don't think this is right either. Huh. Okay. So what we're going to do is we're going to write a little script, little function. So on the server side, so let's do a function. And what we're going to do is this function is going to, so we'll do phylo region to df. And it's actually phylo region summary. Okay. So we have the PR, and then, okay, so what we're going to do is we're going to take PR, and from there we're going to pull out the membership. Wait. What is this? Grids cluster evolutionary distinctiveness. Oh, wow. Can I use that? And this has all these summary stats next to it. Okay. I'm gonna make this simple. We are only going to include cluster and n. Okay. And this is so easy. So this would just be membership and then group by, we'll do cluster and then summarize, n is equal to n. And then we will, I think, can we just do this? Will this work? Oh, let's load up a lot of packages all at once and ignore any warning messages. The right way of doing things. Okay, so then now we can have our clust df using phyllo region summary pr. Summary pr. Done. Okay, now clust df, let's find it. Look at that. We got what we needed with one simple function. Basically, all it's doing is taking each cluster, grouping them, and then counting the number of grid cells in each one. So number of records, so that's your area, because they're all equal-sized grid cells. So, on our server side, let's do this. Clust df. Okay, a data frame that has metrics for each region. Okay, cool. And let's do this. Presence, absence matrix. So I'm defining all the variables that I have so that if you want to supply your own clust data frame, phyllo region object, and then phylogeny. So let's say you want to supply your own clust data frame that includes other metrics like species richness, distinctiveness, stuff like that. So it would do this. So if clust df is equal to this, then we will now add our clust df here. So basically saying if you've left it blank, this is what you'll use. If it is blank, we will make one for you. If it is not blank, then you've supplied your own, and that's it. Cool. Okay. So now we have here. So clustdf. So this is going to be the input for the region. So this is, we're going to keep this the same. So this is just a filter that filters out our data. A, reactive, row names of clusters. Now clusters is a huge list where each cluster has these variables, and I don't actually know what they're for. This is the presence-absence matrix. This is a presence-absence matrix of each cluster. Okay, so it's a presence-absence matrix for each cluster. Well, that should be easy enough. So we can actually make this based off of clustdf. So if we do cluster, and what we're going to do is we're going to create it from clustdf. We're going to use presab. So I think what we can do, we're going to apply a function over this. Okay, so cluster is going to be a list. We know that. And then it needs to be a list for each data frame. Okay. So first, let's do this. So we're going to repeat as.list. And let's just, okay, wait. Let's actually just make this for loop because I'm much better with for loops. Okay. So then for 1 through, for I in 1 through n row of clustdf. So then cluster I is going to be equal to presab. Okay, and our presence absence matrix is going to be a, so is it okay, so it's grid cells on top. Let's go, okay, why do I have so much random shit open? Let's get rid of this. Because that is confusing me. Okay. Get rid of this. Okay. So what it's going to do is we're going to take the presence absence matrix, we're going to filter it. Okay. So then so let's do I is equal to 1. Okay, we'll do that. So what we're going to do is pres ab filter where call names. No, hold on. Let me look at the dplyr. Okay. Filter by call names dplyr r. Okay. I know there's a way to do this. We need to inject filter as symbol column equals 1 using alternative solution. Hear weird shit outside. Oh, yeah, wait, I don't need to do filter. I can just do select. Oh. Select from PR membership is equal to I. What? Oh, dplyr. It's dplyr. It's dplyr. Must be a simple vector. Okay, where membership. No, that's not right. Okay, PR. So we're looking at the failure region PR. Where PR membership. We're looking at PR membership where in which cluster is equal to I. And we're only trying to get the second column. Data frame is 0 columns. Okay. Select where. Hold on, let's see if this works. So, PR membership in which cluster. So basically, oh my gosh, you can't see anything. I'm so bad at this. So let's start off. So PR membership is going to get us what we think. Okay, yep. It's going to get us that. So if we just try to get the second column, will that get us just the second column? Yes, it does. Okay. Cluster is equal to I. I is equal to 1. That should work, actually. I'm not sure why it's not. Why does that not work? That should work. Well, because I did it without this, but I guess we'll have to do it. That worked. Okay. Wait, but it's not. What? It should just be giving me grid cells, but it's not giving me grid cells? Yes, it is. No.
Oh. This is the PresAb matrix. Okay. No. Okay. Oh. Oh, no. It just... Hold on. There we go. Okay. Is equal to 1, 1, 1, 1, 1, 1, 1, 1, 1. It's giving me the cluster. Oh, I want the first entry. Okay. Haha! Here we go. So this is what is in that output. So Abronia ends will now omitted 1982 rows. I think this is right. So I am just gonna go for it. So if I do this, let's just check it. I got a lot of warnings. Okay. So if we look at cluster, yeah, this did not work. Because it should be more like this. But instead... Okay, so it's not doing something right. Okay. So cluster I, for I number through 1 through n row cluster df, which there should be, okay, 17. Cluster I. Okay, and then also let's do... names of cluster I is equal to plus df cluster I. Okay, so let's start over. Cool. And unexpected symbol. Oh, it went all the way down. Do not want that. Yeah. Okay, here we go. Cool. So boom, boom. Okay, the number of items replaced is not a multiple of the replacement length. Error. Okay, names of cluster I. Oh, this is not how you do this. What am I doing? That was illogical. That's definitely not it. Okay. Names of cluster df. Okay, so let's just see if it looked any different. No, it did not change the names. So, okay, that's fine. Okay, so it should be inputting a data frame into each. So we're taking from the presence absence matrix, so we're taking from presab. We're converting it to a data frame, and then we're selecting that one. Now, is it... Let's see. Let's look at one of the lists. Ah, so it is not preserving the names, is what it looks like, which is needed. Badly needed. I don't think it's actually filtering properly. So select from PR membership, which PR membership cluster is equal to I. So I know this worked, right? Yeah, so this is giving me what I needed. Why is it? I think I might actually need to transpose this. No, because it looked totally fine. So it's saying I have 1900 observations of 214 variables. Yeah, so it's not actually filtering out anything. Oh. Wait. 751. Oh, okay, so, and now I need to do a filter. Filter out the species names. Okay. That's fine. filter where row sums equals 0. Will that work? There's a way with row sums. It's a weird one. Wait. Oh, I see. Row sums of each is equal to 0. Okay. So really it's just the filtering out. Oh, is it because it needs to be call sums instead? Wait. So if the row sums up to 0, yeah, if the row is summed up to 0, oh, not equal to 0. That's what it is. Okay, boom. That should do it. I mean, I said that like 4 times, but you'll see. Okay, so now we have our cluster data frame, our clusters. Cool. Okay. In which cluster row names now does this work? I don't know why it's not working, because I want it to name it. But it's not working. It's actually not naming it. Naming entry and list. I don't know why. I thought it was just names, but I guess that's not it. That is weird. There we go. Now it's got names. Okay, so now we're named up. Cool. Cluster input. Okay, so this should just be fine. I'm just going to assume this is fine. Probably a bad assumption, but we'll get there when we get there. Okay. So this is stuff we will work on at a different time. Just making sure we have everything closed off. Boom, 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 boom. I don't know where this is coming from. Okay. Cool beans. Okay. So now, so that's the summary. So this is just going to tell us the region that we've chosen right here. Now let's do a tree plot. Okay. So A, row name, clusters, input region. Cluster. Okay. A is an A.tree label. And then filos up, keep that tip, tree A. That should be fine. This actually should just work perfect. No worries there. Now then, input region, tray A in tree.label, call df, blah, 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 blah. The nice thing is, I think I can just get rid of these geom labels, geom clade labels. Okay. Okay. Render leaflet. So this is the actual shape. Okay. So we are not going to do this first one, and we're not going to do mean edge. We're not going to do that. But I am missing a... right, there's something weird with this. Okay. Okay. So SF simp will be my SF. Okay, so let's go make up a thing for SF simp. So this is going to be, I think this will be very easy to do. So if we go back up to here, df felt. Okay, so let's do SF simp is going to be PR shape st as oh, I should not have overwritten that. Oh well. So can this just work as is? Let's just go from there. Okay, name might actually just work perfectly fine. Add polygons, SF sub, which we have there. So this will highlight it for me. Okay, so these are my bioclim variables, which I am actually going to just remove. Okay, let's just make an empty row. Boom, boom, and then one more. I think this is all good. Could not find function fluid page. Library shiny. Okay. If clust df double equal sign. Okay. Okay, we're just gonna ignore this for now. Cool. Oh, stop it. Okay. So let's get this going. Let me make me small. Argument is missing. Okay, so we're getting some errors, which is fine. I don't have a default. So it is highlighting the regions appropriately. It just is not coloring them in any meaningful way. Okay, so that's easily doable. And then we do have this down here. Now, what I'm thinking might be going on here. So first off, let's check this. So reactive is equal to input region. And then selected is unique cluster 1. Let's try that. Because I think it was trying to select a phyla region that did not exist. Was the thing. So. Argument is missing with no default. Error object object. So that is everything that is showing up on this right-hand side. So we're missing our summary and tree sub. Okay. So render UI on the summary, paste phyla region as numeric input dot region. That should work. Okay, so on tree sub, okay, so we got a cluster on there in tree. Oh. Oh. Okay, hold on. So everything here is just saying tree. So let's just say tree is Philo. So that's on me. Okay, because the tree is wildly incorrect. So, because the tree that I had I was loading in was just for turtles, based on the old one. So we just change everything to tree. It should work. That should fix any of those issues. Okay. So, this is still looking like the turtle phylogeny. Okay. And then row names. Object input not found. So up here, select input region, which is selected. Okay. Row names of cluster. Yes, subsetted by the input region. The first one. Okay, so this should get me. So if I did something like row dot names of cluster 1. Maybe that's the error. Okay, let's redo both of those and run this. See what happened. See if what happens. Okay, so it says listening. Warning in paste. Argument is missing with no default. Up in render UI. Okay. So up in the render UI. I'm going to get rid of these blank ones, just in case they're messing things up. It will affect how everything looks. It says argument is missing, so I'm missing some argument on the, it says in the paste function on line 99. I don't have. Will this not work? That'll work. As .numeric input region. I think it's all falling from this input region issue. Okay. So unique PR cluster. So selected should be null. Ah. PR. Oh my god, it's membership. Membership. Oopsies. There we go. Now we can maybe get some more stuffs. Okay, let's see. Okay, now let's run it again. So this is basically our Shiny applications. Just running. Okay, now it's selecting region number 1. Huh. It is still using the incorrect tree. That's funny. Okay. Yes. Hold on. Did we not have... I might have just realized that I don't have the... Oh, I never loaded in the phylogeny. That would make a lot of sense. Okay. We're gonna go to outputs. Oh my gosh, where is my outputs folder? There we go. Jesus Christ. Okay. PhyloTC. Is that what I'm saving it as? No. Wait. Yes. Yeah, Philo raw A. Okay, Philo raw A. Okay, now let's try this again. I was like, those are turtles. These are not amphibians. Oh, okay. Sick, bro. This is looking mostly right. Let me go to 17, which is way the fuck down here. Adelopus, Rhinella, Pristomantids. Yeah, okay. I can say with some fair degree of certainty this is pretty much correct in terms of it is filtering the data set here. Yeah. Okay. But the big phylogeny looks fucky. Oh. Can we preview this tree? In A input. Okay, let's make an A really quick so that I can actually have something here. Input.region, so we're just going to say this is region 1. Okay. So call is equal to, color is equal to call, group is equal to call. Okay. Branch length, none. Okay, so what happens if I make the tree scale different? What does that change again? Okay. What did A even give me? Is an empty character. Oh. Okay, wait. So Oh. Oh, okay. Hold on. Well, it should just be cluster. That's probably the error, but I think I just forgot to change it. Clusters to cluster. Let's see. Haha, haha. Oop, you might have heard that. I'm so sorry, but I'm not actually sorry. Ah, perfection. Okay. So I don't know why this is so crazy. So tree full, not what I'm caring about, not what I'm caring about, not what I'm caring about. Philo sub, okay. Tree scale, width, let's make this 80? I don't know, maybe that's wrong. Let's find out. Oh, wait. Okay, X, stop, okay. Boom, boom, boom. I don't know what 80 means, but okay. I might have made it too big, but we'll see. No, oh, it's just being squished inside of this column, or this row. So I think the trick... so it's in this fluid row. Wait, they're in the same fluid row. Column. Width is equal to 3. Is there like a sidebar panel? Sidebar panel. Oh, we have the summary here with tree sub. Okay, let's just change out the UI a little bit just to see if that'll fix anything or make it look a little bit better. Unexpected. Oh, yeah, I can get rid of that. Okay, I think that gave it a little bit more breathing room, but it's still just being crushed. I just realized I could load this into Biodiverse and be done with it. Wait, what the fuck, bro? Okay, hold on. Guys, I'm gonna stop working. I made a promise to myself. It is already 5:40.
And I'm just now realizing that, yes, it's not.
I'm gonna go.
Toodles.